We have learned how to differentiate a function once. But what if we differentiate the derivative itself, which is obtained after the first differentiation? Like if y is equal to x cube, we differentiate it once to get dy by dx is equal to 3x square, right? Can we differentiate 3x square again? Yes, we can. And it will give us the second order derivative, d2y by dx square as 6x. And we can continue to get the third and higher order derivatives like d3y by dx cube will be 6 and so on. So differentiation doesn't necessarily have to stop after the first derivative. We can differentiate the derivative itself to obtain the next order derivative. So higher order differentiation simply means differentiating a function more than once. In general, the nth derivative is denoted as d to the power ny over dx to the power n. A very bright morning, guys. In our previous lectures, we have seen that the first derivative tells us about the rate of change of a variable. For example, if distance is a function of time, the first derivative gives us velocity, which is the rate at which distance is changing with respect to time. But the rate at which velocity changes is acceleration. Therefore, mathematically, acceleration is the second order derivative of distance with respect to time. Today, we will learn how to find the second order derivative and higher order derivatives and understand their notations. If y is equal to f of x is a function of x, then the derivative of y with respect to x is given as dy by dx, also written as f dash x. This is the first derivative of y with respect to x. Now, if this first derivative is differentiated again with respect to x, we obtain the second order derivative d2y by dx square, also written as f dash dash x. If we differentiate this second order derivative with respect to x again, we get the third order derivative d3y by dx cube or f dash 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 x and so on. This process of differentiating more than once is called successive differentiation. Let's solve some questions on second order derivatives now to understand better. These are the questions that we'll try to attempt today. Let's start with the first one. Y is equal to 2x to the power 5 minus x cube plus 3x square plus 7x plus 10. Find the second order derivative of this particular function, that is d2y by dx square we need to find. So differentiating this equation with respect to x, we get dy by dx is equal to 10x4 minus 3x square plus 6x plus 7, and the derivative of constant 10 is 0. Differentiating equation 2 with respect to x, we get d by dx of dy by dx. So we are differentiating dy by dx again, so we write d by dx of dy by dx is equal to d by dx of 10x4 minus 3x square plus 6x plus 7, which is the derivative which we obtained in step number 2. So we get d2y by dx square on the left hand side, and the derivative of this function is 40x cube minus 6x plus 6. The derivative of constant 7 is 0. So this is the answer. Let's see the next one. Y is equal to 3x plus 5 over x plus 7. And we need to find the second order derivative d2y by dx square. So if you see carefully, this function is of the order u by v. And if y is equal to u by v, we use the quotient rule for differentiating. So dy by dx will be equal to v into du by dx minus u into dv by dx, and all of this over v square. So we get dy by dx here is equal to v, which is x plus 7 into d by dx of 3x plus 5, that is du by dx, minus u, which is 3x plus 5, into d by dx of v, which is x plus 7, and all of this over v square, that is x plus 7 whole square. Simplifying, we get x plus 7, the derivative of 3x plus 5 is 3, minus 3x plus 5, and the derivative of x plus 7 is 1, all of this over x plus 7 whole square. So we get 3x plus 21 minus 3x minus 5 over x plus 7 whole square. 3x and 3x cancel out, so we get 16 by x plus 7 whole square. This is dy by dx. We can also write this as 16 into x plus 7 raised to the power minus 2. We brought the denominator into numerator because we want to differentiate it one more time. It's easy if it's in the numerator. Let's mark this equation number 2. So differentiating equation number 2 with respect to x, we get d2y by dx square is equal to 16 as it is into minus 2 into x plus 7 raised to the power minus 2 minus 1, which is minus 3, and into the derivative of x plus 7, which is 1. Finally, we get d2y by dx square is equal to minus 32 over x plus 7 whole cube. See the next one. Y is equal to log x over x. Find d2y by dx square. Now here also we can write this equation in the form y is equal to u by v, and here also we'll use the quotient rule. V du by dx minus u into dv by dx over v square. So here we get dy by dx is equal to x into d by dx of log x minus u as it is, which is log x, into dv by dx, which is d by dx of x over x square. Simplifying, we get x into derivative of log x is 1 by x minus log x into derivative of x is 1 over x square. This x and x cancel out. We get dy by dx is equal to 1 minus log x over x square. Now if we see, this again is of the form u by v. So we'll again use the quotient rule here. d2y by dx square, differentiating again, we get x square into d by dx of 1 minus log x minus u into d by dx of v over v square, that is x square ka whole square. We get x square into minus 1 by x, because the derivative of log x is 1 by x, minus 1 minus log x as it is, into 2x over x to the power 4. We get minus x minus 2x into 1 minus log x over x to the power 4 is equal to minus x over x to the power 4, and we get inside 1 plus 2 minus 2 log x. So d2y by dx square is equal to 2 log x minus 3 over x cube. Let's see the next one. Y is equal to 2at and x is equal to at square, and we need to find d2y by dx square. That is the second order derivative. Let's name this equation number 1 and this one as equation number 2. Differentiating both 1 and 2 with respect to t first, we get dy by dt is equal to 2a and dx by dt is equal to 2at. Therefore, dy by dx is equal to dy by dt over dx by dt. So we get dy by dt is 2a over 2at. 2a and 2a cancel out, so we get 1 by t. Therefore, dy by dx is equal to 1 by t. Or we can write this as dy by dx is equal to t to the power minus 1, taking it into the numerator. Differentiating this equation, we get d2y by dx square is equal to minus 1 into t to the power minus 1 which is minus 2 into dt by dx, because we are differentiating this one with respect to x. Now if we see, dt by dx is the reciprocal of dx by dt. So dt by dx is 1 by 2at. We get d2y by dx square is equal to minus 1 by t square into 1 by 2at. Finally we get minus 1 by 2at whole cube. Let's see the next one. If y is equal to x square plus 1 by x square, then show that x square d2y by dx square plus x dy by dx minus 4y is equal to 0. So in this question we need to prove this equation in red. We need to find the second order derivative also. So let's start. Differentiating this equation with respect to x, we get dy by dx is equal to 2x, which is the derivative of x square, plus minus 2 into x to the power minus 3. So we do the differentiation of 1 by x square by taking x square in the numerator. It becomes x to the power minus 2. So that is why we get the derivative as minus 2 into x to the power minus 3. Simplifying, we get 2x minus 2 by x cube. Differentiating again with respect to x, we get d2y by dx square is equal to 2 minus 2 into minus 3 x to the power minus 4, which is minus 3 minus 1, so it becomes minus 4. Simplifying, we get 2 plus 6 by x to the power 4. Or d2y by dx square, this 2 comes on the left hand side, minus 2 is equal to 6 over x to the power 4. We can write this as x to the power 4 into d2y by dx square minus 2 into x to the power 4 is equal to 6. Taking x square common, we get x square into x square d2y by dx square. We took x square common and not x4 because in the equation that we need to find, it is x square into d2y by dx square. So we wanted this particular expression. Minus 2x square minus 6 is equal to 0. Dividing whole of this equation by x square on both the sides, we get x square into d2y by dx square minus 2x square minus 6 by x square is equal to 0. Let's name this equation number 3. Now we can rewrite equation number 3 as x square d2y by dx square as it is. Now this expression minus 2x square can be written as minus 4x square plus 2x square. Can we write this in place of minus 2x square? And in place of minus 6 by x square, we write minus 2 by x square minus 4 by x square. So if we solve this, we get minus 6 by x square is equal to 0. So x square d2y by dx square plus 2x square minus 2 by x square minus 4x square minus 4 by x square is equal to 0. We get x square d2y by dx square plus, taking x common outside, we get 2x minus 2 by x cube minus 4 into x square plus 1 by x square is equal to 0. Now if we see, this part is dy by dx and this is the value of y. So substituting these, we get x square d2y by dx square plus x dy by dx minus 4y is equal to 0, which is what we wanted to prove. So it is proved. So these are the questions that we have done today. I am leaving the last one for you to try. It's quite easy. In case you face any difficulty, then do mention in the comments section and I will try to take it up in any of the future lectures. Just to remind you, differentiation is a complete course on this channel. This video that you are watching now is the 7th in the series. The lectures introduce the concept of differentiation in a step-by-step manner with lots of questions solved on each topic. You can watch them in order for better understanding and clarity. And yes, definitely watch the first lecture, which is essentially an introduction to differentiation with a visual example. Let me know your suggestions and inputs in the comment section. Do like and share the videos and subscribe to the channel. Thanks for watching. See you in the next. Bye-bye.